Let's look at how we can use objects in Java. Right now we have used string objects, but strings don't actually support, they are kind of somewhere in between an object and a primitive because we have so many facilities with Java and strings. We have seen primitives like ints and booleans, right? And now we will talk more about objects. We have used them a little bit, but not too much. So as for examples, we'll use point, rectangle, and dimension from the java.awt library. I will be using JShell, which comes with Java 9. And so it basically works as an interpreter or a REPL for Java. The full name of the class is java.awt.point, but if we use an import statement, we can avoid typing all that stuff. So I can create a java.awt.point variable. If I type, and we create objects with the new keyword, right? I could do this, and that creates a new point, and it has, since I didn't pass any parameters, it tends to initialize to something reasonable. So in this case, it's a point with x0 and y0. If I don't want to be typing all this stuff, then I can import point, and then after that I just need to use point instead of the whole java.awt.point. So I'll do point p1 equals new point, and you need to go look at the documentation for the specific class. The point class has x and y, and I can pass it to the constructor, and it will initialize to that x and that y. And JShell actually prints them prettily. Now, I can also, once I have variables, I have two variables now of type point. I have p and I have p1, right? I can do p1.x, and that will give me the value of x. The value that I put here, the value that this thing actually prints, right? Which is the value 3. I can also do p1.y, that will be 4. I can do p.x, and it's 0, right? Also, objects have methods, and it is fairly common to have what we call getters, which are methods for getting the value of all the internal variables of an object. So I have p.getX. In this particular case, the getters are not quite the same thing. They're actually returning floats rather than ints. But it would be very common to have setters too that have set. So for many cases, I would have things like this. But in this case, we don't do it. For the point class, they didn't follow the convention. Now there is kind of a strong convention to have get whatever and set whatever. And it is actually not very common to have the fields be public. For the point class, the designers of the AWT library of Java decided to make them public, and it makes perfect sense, but many other cases they will not make them public. So I have my objects, I create variables, right, by using the name of the class as a type, and I can access, once I create variables, I can access the fields individually, right, and call methods. So I can do p.x, that's p1.x, sorry, that's accessing a field, or p1.getX, and that's accessing a method. I can also call other methods. For example, they appear to have a translate. So let's see, p1.translate to 3, and let's see if that does what I assume it does. Oh, so now P1 was translated by 2 on X and 3 on Y. So it was 3, 4, and now becomes 5, 7. You need to go look at the documentation to figure out what each one of the methods does, right? We have another class, which is rectangle. Let's go play a little bit with the rectangle class. Actually, if you think about it, a rectangle is going to be a point and then a width and a height. And so let's look at the dimension class first. And I'm again gonna import it just so I can do dimension d1 equals new dimension. And in this case, what I'm passing is the width and the height. So I can do d.width, d1.width, and it's 3, and d1.height, and it's 4. I can also do d1.get width, and actually d1.get size, and that actually returns the same dimension. They do it for inheritance, which we'll talk later. We have mentioned that one of the common methods is toString, and that will return you a string representation of the object. And they are, in this case, they're actually nice, and they return this whole thing. A couple of things. We have one dimension, d1, right? So let me create a new dimension. Dimension d2 equals new dimension, and I will use the same 3 and 4. Now, are these the same object? d1 and d2, are they equal? And so we have this distinction between they are the same object, and that's what equality checks, the equal operator. It's identity, and it will tell me false. They are not the same object. They are two different objects with the same values. I can ask with the dot equals method, do they have the same values, or are they the same, right? Are they equal to each other? And in that case, it would return true. This dot equals is defined by each class, and it's kind of semantically, are they the same value? Whereas this is, are they the exact same object, the exact same thing in memory? With primitives, our variables actually contain the values. With objects, the objects live in memory independently, and our variables contain a reference to the object. In fact, we could do d2 equals d1. What this does is now d1 and d2 point to the exact same object. So if I ask, are they the same? I would get true. And if I could create a new object. Let me call it d3. d1, d2, d3, they have the same value. d1 and d2 are actually the same object. So if I do d1.x equals 20, this changed width and height. This changed d1, but it also changed d2 because they are the same object. It just changed that object that d1 referred to. So it also changes d2. If I ask d2.width, I will get 20. However, d3 was not affected because it's a different object. And this is important to keep in mind what's the memory model for objects, and this difference between identity and equality, and this idea of aliasing. This is a dangerous thing because now d1 and d2 are two names for the same object, for the same thing. So when I change one, like this, I may be changing the other one and not me too. And so that is also important.